Okay, so the next part of this, a particle, it says 5 commandments of particle motion. This is not something that you need to memorize. It's not something that they're going to ask on the AP exam to say, what are the 5 particles of, or 5 commandments of particle motion? This is just something to put this all in the same place so you can reference this later. A particle is moving to the right when velocity, v of t, is greater than 0. So the same thing we said 2 pages ago, we're just saying it again now. Our particle is moving to the left when v of t is less than 0. The speed of a particle is increasing when velocity and acceleration have the same signs. So this is like, if you're moving in, I don't know, I know this is about particles, but let's say this particle is in a little car because it's easy to think about right and left. The speed of a particle. Velocity, you can move right, you can move left. If it's moving right, it's positive. If it's moving left, it's negative. The speed, we're talking about if it's increasing or decreasing. So it just means, am I going faster or am I going slower? So in this one, the speed of a particle is increasing when velocity and acceleration have the same signs. That means, let's say velocity is greater than 0. So that means the particle is moving to the right. If acceleration, if there is a force, if velocity is changing at a positive rate, acceleration is positive, that means it's being pushed further this way. Like it's like pushing on the gas pedal. If it has different signs, so opposite signs, that'd be like velocity is positive, acceleration is negative. So acceleration, you're slowing down. The rate at which velocity is changing is negative. There's going to be, like, you're going this way, but you're putting on the brakes where the particle is. Same thing here. Velocity is negative. All that means is it's moving to the left. If acceleration is also applying a force that is moving to the left, the speed itself is increasing. This is done. Speed is increasing. If velocity is moving to the left, or I said that weird. If the particle is moving to the left, so velocity is negative, and acceleration is negative, so it's applying a force to the left, the rate of change is negative. By just then this velocity, I said that weird, the speed is increasing. I'm going to change this and go in the opposite direction. Okay, velocity is negative, which means the particle is moving to the left. Acceleration is positive, which means it's applying force to the right. The particle is slowing down. So if you messed up on that one part because I messed you up, it's kind of like me being here. Okay, last one. V of t is equal to 0. So that means velocity is 0, but the acceleration does not equal 0. The particle is momentarily stopped and changing directions on the x-axis. So that means, like, it's kind of like that second when you're, I don't know, if you're in a car and you're pushing on the gas, but it hasn't quite, your car hasn't started yet, but you're already applying a force. That's what's going on. If you need a minute to write these down, stop this at this point, take a second, write it down, make sure all of these make sense. But I can keep going because you can pause this. Okay, so suppose the velocity of a particle is given by this function. So v of t is equal to blah, 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 where t is greater than or equal to 0. And most of these t is going to be greater than or equal to 0 because t is time. So t is measured in minutes, v of t is measured in inches per minute. So find the values of v of 3 and v prime of 3. Okay, v of 3. So if I put in v of 3, I'm just putting it into this function. I need to wait on this. 3. And if I do this and I have some math magic, I get that this is 245. If you gave me an answer of 245, I'd say, fantastic, you're wrong, because you didn't put units on it. And it will be the same on the AP exam. If you do not have units, you do not get credit for your answer. You'll get credit for the step and knowing to put in 3 here, but, you know, it's not quite good enough. So v of 3, in this one, I have to think about velocity. It tells me up here it's measured in inches per minute. Now my answer is good. v prime of 3. In order to do that, I need to find v prime of t first. A couple ways that you can find the derivative. You could take t plus 4 and square that and actually figure it out and then multiply that times t plus 2 and use the power rule, but ain't nobody got time for that, so I'm going to do the product rule. T plus 2 is the first quantity times the derivative of the second. But look, wow, it's a chain rule. Okay, so I'm going to take 2, leave the inside alone, decrease the exponent by 1, multiply by the derivative of the inside. And this one, the derivative of the inside is just 1. So that's it. First times the derivative of the second, plus the second times the derivative of the first, the derivative of t plus 2, which is 1. And again, math magic to do this, v prime of 3, putting in 3 at all these places, you should get 119. Again, not good enough unless you have units, so it's 119. But think about what these units are. So velocity was given in terms of inches per minute. So velocity was inches per minute. And I'm finding the derivative of velocity. So I'm really finding the change in v over the change in t. So I'm changing in inches per minute over the change in time. So this should be inches per minute per minute. I don't care if you write inches per minute, inches per minute squared. Either one, but know that you're talking about a rate of a rate. So, v prime of 3 is the same thing as, if it writes it on here, as a of 3. I'm way too fast for this. I'm just going to hold off for a second. So, if we're thinking about this, and velocity, while I'm waiting for this, is positive, and I've got acceleration is also positive. So, velocity, positive, that means the particle is moving to the right. I've got a force being applied to the right. And this one, I can say the speed is increasing. When t equals 3. Okay, so again, if you need to stop it, you can. I'm going to keep going so I can finish this one, but stop it, talk to each other, make sure that you understand this, because it's a pretty big deal. Okay, on what intervals is a particle moving to the left and to the right? When a particle is moving to the left, the velocity is less than 0. When a particle is moving to the right, the velocity is greater than 0. That's it. You don't have to check on acceleration, anything else. You're just saying to the left, velocity is less than 0. Right, velocity is greater than 0. And I know that you're hoping to make a chart at this point, so here's a good time to make it. In order to make a chart, well, we don't even really have to do that, but you'll see why in a second. Most of the time when you get to this point, you're going to have to make a chart to see when it's moving left and right. But v of t less than 0, v of t greater than 0, I want to know when is v of t equal to 0.